course on the first edition said, oh,
They
the
just
second
came out.
edition is here. So anyway, it's worth mentioning just in case. Found a cheaper version someplace else. So Emily,
Yes.
yes, and then Zach is not here yet, and Abby, Liam, Joe Infantino had a work-related thing he had to do today, and Annie, and Jordan, and Hattie, and you're Vic, right?
Yeah.
Yeah. And there might be one more student, we'll see. Everybody has a copy of this. So welcome. Glad you're here. Statistics 252, Mathematical Statistics and Methods, I think is the official title. So we'll be looking at some mathematical statistical principles that govern how you use data and do inference for things in the population. We do some methods like comparing means and a few other aspects of things. Hi. 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 We'll do some computing with the R statistical package so we can implement these things on data sets. The data sets can be large size from different sources, from the book, from other ones. And we do some simulation because part of looking at mathematical statistics is looking at the properties of things. How do things perform over time in larger samples, in replication? We can do that on the computer with simulation. We'll do a little bit of the mathematics, a little bit of the reasoning, but also be able to evaluate things. And just one thing to emphasize, the text is the second, this is the one that's listed at the bookstore. So hopefully that was clear. Since it's 2019, when I first got an online version of it last year, they gave me the first edition, and I started preparing out of that, and then the second. So it was a small adjustment, but they moved a few things around, and we'll do this one. So just to double check that you have the right one to begin with. So I guess a few course mechanics type things. We'll put things on Canvas for most things. Right? So eventually I will post the syllabus. There's not much anything really focus in there yet, but I'll post the syllabus, kind of a course outline for things that are going on. Assignments will be posted in here. Eventually I'll post solutions. Within there, if there's code or data sets, I'll put them there. One nice thing about this R statistical package is if I put an R object in there and you click on it and your computer has R on it, it often just opens automatically, so it will find what you need and can be really quite a quick way to download data sets, series of instructions, commands, and so on. Right, and this is, I've requested that Tegrity record the class. So I have in a mix for sports or public service or move or adventure center or job interview, internship interview, other major thing. If it turns out there's a speaker at an area college or university and it happens to be during our time and it's really relevant for you and you want to go see that, it's a small enough group that we can probably, arrange something, get you the notes online, get this. Typically, if I use the whiteboard as well, I save those notes and then post them to this. There is pages. It's not completely. There will be a lecture, a file section. There will be a file section. I have just not put things there. So eventually, lecture notes would be there. If you click through there, it's empty now, but eventually I'll put the notes there from that and other ones. You'd be able to get lecture notes. So that will be a major way of putting things together. So in terms of the syllabus, I guess I'll just look at the copy that you have. Right, so we'll meet in here the Monday, Wednesday, Friday. My office hours, I have an earlier class in the day, and so I'll have them, I'll find that. Saving second to get that, but we can all look at the same thing. Probably under course information. Right, the syllabus, yeah. Okay. So there's a couple hours around before and after the lunch hour on Monday and Friday. And then on Tuesdays, during the first half of the semester, homework we do on Wednesdays. So that's why it's kind of loaded on Monday and Tuesday and Friday, right? About halfway through, there's a one-day break, and so some of the homeworks at the end we'll switch to do on Friday, and I'll move the office hours to Thursday, so like, kind of about the same times. And by appointment, right? So if you are interested, so that means email me or talk to me in class, and I'll check the schedule. It's very likely that I can have some other times if these particularly don't work so well for you, or something else comes up. Or you want just some time outside of that schedule to talk about majors or minors related to statistics, data science, math, or professional opportunities, internships, jobs, just generally career things about what do statisticians do, where do they work, and so on. I'd be glad to talk to you about that stuff too, either during the regular office hour or some other time. We're using that textbook. We'll use this R statistical package. I know some of you have seen it or used it, but not everybody. And so the philosophy I have is that we'll take it step by step, right? And you kind of learn as you go. I don't know everything about it. I know the things that I've used a lot or regularly. Often I need to look stuff up again, but once you get the kind of the hang of some basics, then you can do a lot more. And it's a very flexible system. I find it effective to use in my applications and consulting and research, because you can easily create files that include series of commands with comments and insert some results in there. And there's very fancy ways to do that. I'm just kind of plug and chug and paste it in there. But it's expandable, and it's a great free resource you can have. This RStudio is a graphical interface that really is nice as well. Right? So prerequisite for this is some calculus class, 150 or 130, or permission. And it's useful if you've seen a course in statistics before. You don't necessarily have to have seen one, because it kind of builds, and with the math background, you do well. But the more you've seen, the more something will be familiar. That says for anybody, it might be helpful at times for some of the graphical representations or summaries or things to look at an elementary statistics textbook. Right? So if you've taken a class before and still have the textbook, then you could look at it. I'll be checking with the library to make sure that they have some copies of some introductory books available. So in case you want to look up some background material, particularly as we get going, that is there. And so we look at some of the major concepts in mathematical statistics of how people in a rational way, in a justified way, take data and make some inferences about a population in different aspects. Maximum likelihood estimation is a big one, Bayesian estimation, but there is quite a variety of ways people have done that. And then, as important as coming up with some theory, is evaluating it. Does it seem to make sense? Does it produce the right answer on average? Does it work in the long term? Does it make, in hypothesis testing, there's two types of errors, kind of a false positive and false negative. What trade-off does it give you there? So we'll look at those trade-offs. Some learning objectives to understand the basic ideas behind some of those, be able to formulate some hypothesis scenarios, to make some confidence intervals and apply some of these to data, looking at some of the underlying assumptions that are there to use in a reasonable way. In terms of what you have to do in the course, so read the textbook and keep up with that. There's 11 assignments posted on there, and you have to turn in 4 of them. There'll be a mix of a little bit of theory, a little bit of application, a little bit of programming. Again, the programming and using the computer will build over time. So there'll be more details given out at the beginning for those. Later in the term, it might say, describe some data. Well, if you've done that on 3 previous assignments, then you can copy over some of the commands and modify it for part of that. Yes?
It says 10.
10 out of 11 assignments.
You said 4?
Oh, maybe
40%.
it's 4% each or so. Did I say 4? Yeah. I didn't even realize that. So either know it's 40%, 10 out of 11 assignments. Yeah. So it's not every week. Yeah, that'd be a lot of assignments. That'd always be like a couple problems every day, right? So, but no, it's weekly things. It's fine to look at the other problems that are in there, even if they're not assigned. And some of them I'll pick out to have kind of this discussion in class so that you can be involved in thinking about it and expressing things too. On the homeworks, you can work together. But everybody has to do their own assignment, their own write-up. Everybody should be able to do the computing, right? And in addition to understanding the theory and writing things out. Some of the homework problems will be, just find this answer or this number, but a fair number of them are going to be interpretation, so expressing things in your own words. A lot of the consulting work I do, ends up being with people who are non-statisticians, so you have to be able to explain. Why do you want a 95% confidence interval versus 90%? What are the chances, of making different errors? Or, say you think that there's 10% of the population who don't record their insurance information right. How many people would you have to sample so that you could detect a certain difference from this 10% hypothesis? And so that's grounded in some of these mathematical statistics ideas, but then you have to explain what you're considering. Right? There's a couple in-class exams that are spaced during the time, and we'll have a review day before each of those to go over material and practice problems. And a final, the registrar has our final as December 10th from 11:30 to 2. That's posted, so I think that's, I'm not sure where that falls exactly in maybe that's early in the week if it goes there, but I didn't really check. There's also, the final part of the grade is this project and a presentation. So it's mathematical statistics, but it does include methods and simulations and data. So there would be a possibility of looking at, there's bits and pieces of the book that we won't do. There's things that you might be interested in from other contexts. You could take a data set, right, that's of interest to you, and analyze it. The contrast to some other classes, you might say, well, if these are the sample estimates, what's the chance that we would have rejected? So kind of simulate something based on the properties of the procedure. So, and for those of you who are in 451 as well, the other class that I'm taking, kind of doubling up, we can talk about the coordination between projects, whether you would do separate things or have one major thing and do two pieces for those that where there's overlap. And so yeah, there's a lot of ideas there, a lot of flexibility. It can be fairly mathematical, fairly computer-based, fairly data-based. So, and it can be adapted to something that you're interested in. Some of these, so I can touch on one or more of the topics in the class. And then this size is a good size for doing some presentations over a couple days at the end, some presentations. And so it's, those I think can be a fun thing. You can think about your audience as the other students who have gone through this with you. Like, what did you do that kind of built something on there? They'll find it interesting because they won't have had the same idea or done the same investigation. And beginning to talk about these kind of abstract concepts in real world terms is something that takes some practice. So hopefully you find that to be an enjoyable way to wrap up the semester on these topics. In terms of religious holidays or accommodations for different learning styles, I'm happy to work with any of you on that. If you're going to miss for a religious holiday or sports or business, interviews or whatever else, try and stay in touch. Let me know in advance. I think it's very reasonable to take an extension or two for a reason like that. Same thing as if you get sick. And we don't necessarily want you coming here if you're going to be contagious. And if through the library office or learning, if there's any documented issue or recommendation, such as taking extra time for exams or exams in another space or anything like that. I'll try to do my best to accommodate that. The notes will be recorded to some degree and integrity recording, so that could help if you want to review anything or see it. Plus, the office hour times are pretty flexible, and it's fine if you come every week, a couple times every week, if that helps. In terms of academic integrity, right, most of that in this comes through the homework. So that you do your homework, write the homework in your own words, and don't just simply copy somebody else's. When it comes to the projects, that you write your own project, do your own analysis and thinking about it. And that will be very important to learning the material and making it useful to you. One other thing I'll mention, or just two other things, is that Statistics 252, and I know that a number of you are math or data science or statistics, either as major or minor, but Statistics 252 does fulfill both one of the requirements for both the major and minor in statistics and in data science. Right? Particularly the minors at St. Michael's are 5 courses, and if you're taking a math major, you might have taken probability, and now this one. Well, that's 2 courses towards the minor. Introductory statistics also counts. Some of the courses in computer science and also data science do. So at this level, for most of you, it's already a second course in this area. So you're partway towards the minor. So if you're, some of you are seniors or juniors, so there might not be that much flexibility in what's left, but it really becomes an option because you've gotten part of the way. So I'd be glad to talk to you about that. There's a number of institutions, organizations, associations, and so on, that are worldwide, American, Canadian, and worldwide, that focus on mathematical statistics and its use in a variety of areas. The Institute of Mathematical Statistics is among the most mathematical of them. American Statistical Association is very broad. Their annual meetings now are getting close to 7,000 people and include application areas in all aspects of society, from sports to business and marketing to genetics, medical imaging, environment, and a lot of the membership are people who use mathematical statistics and methods in some part of their work. So yeah, there's a whole world out there of conferences and people doing research and trying to advance the methods into new areas and new complications. And we'll start at the basic building blocks and really identify many of the foundations on which they base their work. Yep.
So mathematical statistics, is that a distinction? What's that a distinction between?
So statistics in general could just be the use of data and information for some purpose. Some people emphasize with the statistics that it's the gathering, warehousing and transforming, and then using that data for estimation or inference, and then for some purpose, like decision making, kind of the whole process. And the mathematical statistics really does come out of mathematical concepts that say if you have this probability distribution and you're doing a certain estimate or a certain function of the data, what is its mathematical or statistical expectation? What's its variance? How do different changes to the distributions of underlying data change that? As the sample size gets big, what is a limiting distribution? So there's a mathematical limit that goes in there. And so doing some things like that. We do some of the mathematics in this course. The next level at a master's level would do more, and a PhD level would do more of figuring out the mathematics and technical details, how these things work. And some of it for us is looking at the properties of these estimators, so what's the probability you make an error of one type or another, and so those can be done with mathematical computations, doing an integral over a certain space, or they can be well approximated with simulation. So simulation with the power of computers and kind of the ease of some of the programming as opposed to say 30, 40 years ago, right? It's really is a great tool for studying some of those things. Yeah. At the mathematics level, we use some, and depending on what you write on your forms, in terms of background of everybody, we can look at it. There's not much of an upper limit for what we can look at if we want to, but so I think this book's a nice balance between giving an idea of a little bit of the mathematics and some of the theory, but really kind of staying practical. Okay? Any other questions about the course? Think of any? So let me know, and close this. And so the where also you could say that this course fits in, you can think of kind of a big picture of things, where the statistical inference that we have is going to come in. And so if you have a population that you'd like to know something about, right? And this could be a population. Let's see, I'm going to look at the lighting just for a minute. So there's kind of a glare there. Let's put this, that's kind of that one. What's this one? Is that a little better for reading the front? Either way. Populations can be very large, like all the adults living in the United States. It could be an animal population. It could be a population of all the land area in the United States, about every single point, maybe a square meter or square kilometer, right, like that. Other populations are quite small. Right? You could get a population would be all the directors of graduate programs in statistics. Maybe you want to find out about their opinions and things that are going on. That's not insignificant, but it's not in the millions of people. The population often has characteristics. Right, that you're interested in. Average numbers, average rate, rates of certain things, certain percentages that you might be interested, associations between variables that are expressed in one way or another. These characteristics might be described by parameters in statistical models. Right? Sometimes these are called mu for an average, or p for a proportion, or sigma for a standard deviation. We'll go back over meanings of exact symbols as we go through different examples and methods. There could be some regression coefficients, or so there's a whole bunch of different characteristics that we might want to know. And in any population, you might want to know about subgroups in that population. What's the average income among men and among women with certain degrees and years of experience? Right? Our questions, these parameters and characteristics, might correspond to things that are really important to know. If they're presented just abstractly as symbols, it seems a little bit less pressing. But if it's something like, what is the actual return on some investment or some intervention to try to make things better for people, then you'd want to know what that impact is going to be. Some of these might be the difference between two means, difference between two proportions, so you can compare groups or multiple groups, right? And we really would like to know those things and be able to describe them. And some intervention or policy you might suggest might then hopefully impact those in an important way and make something better in society. But we don't have the population, right? Where you can take a sample of some sort. Right? From that, it might be a random sample where we can randomly pick from the population. It might just be what's observational, electronic health records, program participation for people getting welfare payments of one sort or another, volunteers for an internet poll that just plug in their data and go, randomized experiments. So there's different ways you might get the sample, and then you have some data. And from these data, we can calculate statistics. Right? And the statistics just are summaries of the data. You might call them functions of the data. Sample average, sample proportions, sample standard deviations. If you fit a linear regression model, you could get estimates of these slopes in some equation, right? Things like that. So they could be represented by the sample average x bar and the estimated proportion. The sample standard deviation is often S. You know, the regression coefficient, sometimes lowercase. There's different symbols that get used for different things. This is the letter R. Right. Back in middle school, I had a life science teacher tell me, you have to make a bigger difference between your V's and your R's. Otherwise people won't know what they're writing. So it's still a problem. So these statistics, you know, for that matter, you can make different graphs, right? You might be interested in the population distribution. Of some characteristic. This might be referred to as shape. You know, is income, is it skewed to the right with with some really huge values and then a bunch that are tightly packed? You know, that's the way it is. But you know, how skew is it? Is it the same skewness for countries? Is the shape the same? On other things, you know, if you're giving somebody a drug for weight loss, well, maybe there's some individuals that have a certain genetic predisposition with that particular drug to have a tremendous effect. So maybe there's kind of a mixture where most people have kind of a normal bell-shaped distribution, kind of at center, kind of symmetric, not too there. But then there's this other group that's out there. If you have a few of those people that have that genetic interaction, maybe they're a little bit off the scale, a little bit different. So is that shape much different? At the data sample side, you can have graphs of the data, right, our sample graphs, histograms, and so on. We might do box plots. We'll review all those and see how to do a bunch of them in R. R is very good for graphics, in terms of manipulating graphics, adding points in, adding labels, and stuff like that. So, but then the challenge is inference. So statistical inference takes sample statistics and tries to say something about that. Given that we have one sample and one estimate here, how close do we think that x bar is to the truth? So a confidence interval or a posterior interval would give us some idea of where that is, right? Looking at inference.
I cannot understand you.
And so our course is interested in this technique. How should we do that? Given that we have some idea of the population, maybe the distribution, some a priori ideas, and we have some data of some quality, which statistics should we do? Right? Should we do averages, or should we do medians, or should we do some type of trimmed means? You know, what would affect those different summaries? And then how should we do inference? Is there a mathematical rationale for doing a confidence interval on a certain form? And so we gradually, over a few examples and a few methods, generate ideas for doing that. Some will be the mathematical statistical methods that are coded into everyday statistical software and used, you know, frequently around the world. But we'll also look at some that are more adaptable to the extreme situations. So maximum likelihood estimation is one of my favorite, one of the most popular, where there is population distribution. This might be also called probability distribution. Sorry, that's a little hard to read. The probability distribution, so that if we believe that the distribution is skewed, there's options like gamma or chi-square. There's these probability distributions that are skewed. In some biostatistical work, there's survival times, like how long does somebody live, or how long does it take for some event to happen? Like how long does it take for a forest to regrow? You know, if you if you mitigate some disease that's there. So some of those are probability distributions. Describing those mathematical models have some parameters with different symbols typically used. And given a set of data, how can we estimate those and say what are those likely values? Right? If we need to simulate things for the future or simulate a process, there's probably some parameters in there that we could be interested in. And if we have data on one or more aspects of those, we want to say. So we'll look at the different ways of coming up with those. We'll do what I consider the standard ways that inference is done. We'll look at some underlying theories and what we're trying to look at what people were thinking about when they came up with these ideas. Right? Error rates, performance over time. Sometimes it's called operating characteristics of a certain procedure. Right? And so this inference procedure is a set of rules for saying what you do with data, and some of them can be more adapted to others. In new applications with new data structures and situations, people do active research in finding new ways to adapt those to do better. More efficiency for the same amount of data, so you get more out of what you're paying for. It would be a big goal of some of these things. And also covering your butt so that you don't do something completely ridiculous. Right. So yeah, that's a lot of what we're going to talk about. But any questions or thoughts? So, at the end of the semester, maybe a few times through, we'll probably come back to some of this picture and figuring out what part of the process we're dealing with here. For Wednesday, we're going to look primarily at, start in looking at things in chapter 3 of the book. This is where we get some introduction to hypothesis testing. Hypothesis testing is, part of this inference procedure. So if you had a hypothesis about any of these parameters, or maybe you had two groups, are these groups the same? That's a hypothesis. Either they're different, same, or different. And we want to make a decision. So the things about inference procedures start there. So we'll start taking a look at that. Friday, the plan is to do more with the R statistical package. The book has a little bit of that embedded with this. So if you look ahead to chapter 3 on that, there's some graphs, there's a few comments on some data sets, there's some R code. So I would request that you look at chapter 3 to get kind of an awareness of what's in there. And maybe we'll read a few of the definitions to see, what is a hypothesis test. If you've taken an introductory statistics or another course that uses any statistical testing, some of that basic background would be familiar, but you don't necessarily have to have that to be in this course, of course. And then we'll do more with the R statistical package for implementing a few of these things. Yes?
Well, should we bring our computers to class?
You could, you might want to, that Friday, you could, because you could install it right then and start using it. With a fast internet connection, it can take 5-10 minutes to get it installed and start working. And so that would give you a chance to do some of those things. The material in chapter 1 gives some interesting descriptions of some data sets that are in the book and some general ideas. Chapter 2 does more with some displays and some data summaries. We will, cover this information along the way. Right? That is, these data sets will be referenced in there. So it might be useful to kind of peruse some of the data sets. We won't do all the details that are there. The different displays and data summaries will say things about those as we go through different examples. We don't necessarily need to do all the types of plots and all the data summaries right at the start to get started on a little bit of hypothesis testing. So these two are always going to be kind of resources as we get going. Right? And so, for example, they have an online version of the case study, the book. So one of them, the data sets, there is about flight delays. I think it's also just interesting to look at the types of variables, the variety of variables, variety of applications that get used in this, and think about that. So there's a number of flights, the carriers, is United or American, flight numbers, destinations, departure time recorded, and then day. This looks like it's just a partial view. It looks like there's a few other variables that aren't included in this, right? Destination, day of the week, month, delay, right? Minute delayed. Are they delayed more than 30 minutes? And then the length of flight, right? So obviously, one question could be comparing these two types of airlines, right? Does one seem to have more delays? Is there any other question you might want to ask about these data? Yeah.
If particular flights to like one destination are more frequently delayed than others.
Yeah. Is it bad to fly into Chicago during the windy part of the year? Or is it bad to fly in the wintertime in certain places, right? Is it bad to fly to Florida during hurricanes, season, something like that? Yeah, so really each of these could, if you're creative, you can come up with a number of different things. Is there any of these variables? So there's some choices embedded in how they've presented the variables, right? Do you feel any of the choices and variables they have is limiting, or would you think about using it another way? Yeah.
For month, they only have May and June.
Yeah, it's just, so I guess it wouldn't be the winter time, just May or June. They have a small segment of data. That might reflect that this is a textbook example, industry presumably would have it 12 months, but that's good to note, right? So any conclusion about the outcome, it's only really kind of going to generalize to that small, right? That says something about what the population is. These data are relevant for that time period. Yeah. No. Yes.
Well, the 30-minute mark seems to be an important one because they have the specific guidance for
right.
whether or not it's delayed 30 minutes.
So maybe there's a industry standard, but you could do 30 minutes, half an hour, 1 hour. You could do extreme. Is it more than 2 hour delays? Right? And you might get different ratings of which one you look at, right? Anything else different? If there's any other variable that you might like, would you like to add any variable to this data set? Yeah.
I think the weather would be something to take into consideration.
Yeah. If it's raining that day or something, a thunderstorm moving through, you could maybe do, if you knew the flight and the date and the city of departure or destination, is there a thunderstorm at either one, right?
We don't have the departure city.
You don't have the departure city.
They only have the destination.
Yeah, that's been interesting, isn't it? So if you fully wanted to model it, you probably would want to do something like that. Yeah, so you could think of a number of other things. What type of aircraft is it? Is not there. That's been an issue, right? Unfortunately. How old was the airline flying? Right? If it's a new one, you hope it doesn't have as many mechanical delays. It's an older one.
Or what pilot is flying.
And yeah, you get the pilot and the crew, and was the control tower fully staffed, right? Sometimes they're running on short shifts or something. Was it a holiday period? This is, if it's later in June, you're gonna get past, well, there's the kind of colleges are getting out, and then high school, the public schools are getting out, so it's gonna get more or less, maybe something about the total capacity of the airport. Right? If the airport's running at 80% capacity, maybe there's less likely for a delay, but if it's, excess. So anyway, this is one variable, one there, data set. Here's another one, right? Birth weights of babies. This might be all the variables: mother's age, mother's tobacco use, gender of the baby, weight at birth, gestation time. And there might be different ones. There's different, a small subset here and a larger sample there. Sample size will impact our statistical analyses. because some aberrations, some unusual observations could impact a small data set a lot more than a big data set, right? One very large value, if you're averaging things together, makes more of a difference if it's a small denominator. Right? For this one too, you could think about any number of other variables. What else do you think would affect either the gestation time or weight at birth?
If the mother drank alcohol.
Alcohol and drugs, if there's any way to record that. I mean, there's been a series, the 7 Days newspaper, which is a free newspaper for Burlington. The last issue was on mothers and opioid crisis and what happens to children who are born when the mothers were using drugs during that time. So that would make an impact. Right. Age of mother, BMI of mother. Did the mother have any prenatal care? Maybe that's related to insurance. Yeah, so you can keep going, right? What's the social context? Is there a partner with the mother, or employment of the mother or a partner, right? Is it a first birth or later? Yeah, so many different, any of these data sets you can speculate about interesting things that would be there. Right? There's one on, right, so sometimes, the data sets are smaller. This one is about repair services to exchanges. And every once in a while, you can, if you look through these, you can just keep in back in your mind, does something look unusual in the description? Here's this data set. So just kind of, anything stand out in that description?
How many fewer CLEC customers there are?
Yeah, there's only 23 CLC customers for some reason, right? That's going to affect, surely that's going to affect our statistical inference. We don't have much information to make a very good, strong statement about that. And so if we're looking at the difference, somehow it's going to figure into things. This mother wanted to do this, mother used tobacco. How do they know, right? Is it self-report? Is it taking a hair sample and doing a testing? Yeah, for things like alcohol or drugs, then that's harder to know. So what's the quality of some of these variables, right? We won't necessarily take up these things so explicitly, but if you're reading about data sets, it's not too interesting to me just to read a list that says here's a variable and so on. Kind of thinking about a few of these questions, for yourself, maybe will help you remember, what was the context of that data set? Because as you read it later on, it could kind of, just trigger some memory. Oh, that's what's in this data set. Right? This was in Iowa, people who were released from prison during the first half of 2010, and whether they were arrested again. Right? Recidivate is to be arrested again, yes or no, and these are the variables that are there. Right? Is there anything interesting in this description to think about? They've made some choices about ages. There's some choice about how they record race, ethnicity. Many data sets have a race variable and a Hispanic variable, right? Because you can have different combinations. But some put them together, and for analysis purposes, maybe you would split it in different ways or group it in different ways. This is in Iowa. Maybe some of these groups are kind of small in certain communities. So again, sample size. Gender increasingly could be one that's recorded in different ways.
The type of crimes
Yeah.
they're focusing on.
Yeah, there's a lot of range within that,
Mm.
right? Yeah. Is it a violent crime? There's one aspect that seems totally missing from this, right? And that's total history, right? How many times have people been arrested before? Right, if somebody's 32 and it's their first time for a misdemeanor that ended up with them, a couple days in jail, it's a lot different than somebody that's spent half their life in jail, right? So there's many choices, and as it goes through different things, we will do something later on sampling. Some of these topics that are in the first chapter kind of have their corresponding things in later chapters. So we will do a little bit more about sampling. There's a little bit of math notation for combinatorics. We'll do a little bit more of that, as we move forward within a method, right? So, but then there's some definitions of parameters and statistics. And I think for me, one reason for not doing in depth the first chapter that throws in something like the probability density function for a normal. If you're taking probability, you've seen this function, but it's not critical for us right now. We're doing. Eventually, we'll come back to using this and doing things with the likelihood, doing this as a likelihood function and getting independent observations and multiplying these things together and taking logs of it and differentiating and doing a mathematical aspect of things. But it's a little bit more than we need right now as kind of an introduction. And I think the data sets and kind of sets, by the time we'll get through, if you would come back and look at this, and after a couple of the weeks, a lot of the topics in here we will have hit. But we'll start with the third chapter for introduction to hypothesis testing and use that as a vehicle to introduce the R computing and get rolling. So let's see, we started at 1:30. So we do have a little more time. Not that, right? There's other neat data set like this general social survey, right? Is a large scale real survey. National Opinion Research Center is at the University of Chicago. This survey has been going for many, many years, like maybe 50 years. Right? And so it tracks changes in many of these variables over time. And it's an hour survey, so it's people might be answering 100 or more questions. And there's been modules that change over time. Right? So some things about employment, some things about education, insurance, health, but public opinions on a number of things, right? So kind of by contrast, this one just had 3 white, black, and other. Now federal surveys, as of 10 or 15 years ago, all are supposed to have many more categories. Perhaps it's just for this data set in this book that it's only 3, but to be fair and really represent the diversity that's out there, typically they ask many more categories, or allow people to self-identify and then code it into categories for the purposes of analysis. Right? But this is that's pretty limited in comparison to what others do. There's some fun ones, beer and hot wings. So this one, a student, right, at a particular bar in Minneapolis, right, asked patrons to record their consumption of hot wings and beer over the course of several hours. And so the question is, well, one question is there a difference between male or female in terms of these things? Right? Any other questions that you might think of?
How much beer you have influencing how many hot wings you eat.
Yeah, is there any association here, right? It's, some bars, have kind of a free snacks happy hour. Those snacks are pretty salty. Not necessarily the healthiest thing in the world, but they're kind of there to get people to, drink more and hang out, right? Come there instead of someplace else. But anyway, you can look at this, right? But in terms of really doing scientific analysis, is there any issue?
30 observations.
30 is small, right? it is one location, one time period, and so that's limited. It might generalize to similar areas, similar populations, similar cities, something like that. But did the people know that they were being monitored? Right? They're asked to fill this out. Right? So if you're asked to fill out, how much are you going to drink? How much are you going to eat? Right? Is that going to be any different than normal behavior? Right? Possibly. Right? That it's hard to do it. It's kind of fun, but kind of some things extraneous to the kind of mathematical statistical process are still important in terms of how you state conclusions. Some environmental data sets. So just the variety of data sets I think is interesting. I'll bring in some others that I like to use from time to time. Right, and so it's kind of perusing the first couple chapters will give you some ideas of what some of these data sets are. As you go through chapter 3, if it mentions a data set, you might look at the analysis and try to think of, is there any issue with recording anything? Is there any issue with how they selected from the population? If I had to pick one more thing to know or one more question to ask, what would I do? And we'll use our statistical, develop a statistical methodology and the theory in light of some of these questions we might ask. So it's a little introduction to the book to get going. And we'll come back on Wednesday and take up some of the what is hypothesis testing. All right. Oh, sorry to do this. I almost let you go. The class schedule that you have a copy of is I'll fill in a little bit more of that. Yeah, you can hand those. I just want to point out just a couple of things here. Some of the dates for the homework are pretty much set. Friday, September 6th is the first department's seminar for mathematics statistics. So maybe some of you are presenting. You're presenting here. And so these are students presenting on work that they've done over the summer, mathematics, computer science related, but also statistics, data science. So that's, I think, pretty interesting. The exams are posted here in terms of the times. There is, the college break is there. On that Friday, there's a meeting for the Vermont Genetics Network, which is a series of research topics, and I'm participating in that. And they put it on Friday. So I'll be participating in that. That day is the Pi Mu Epsilon is the Math Honor Society seminar. The speaker is talking about mathematical models and related to genes and gene expression and combinatorics. It's kind of statistical in that, but there's going to be some decision making about what model or how do you represent something. So that seminar is there. And about this point, as I mentioned, the homework will be switching to Friday, so we'll shift office hours in there. But just a kind of a couple details in there about those times. Besides missing that one day, I'll be gone that Monday before Thanksgiving. So we won't actually have class that day. But by then you will have your project assigned, probably a data set and things like that. So that would be a very good time to use for doing that. So if you attend one or two of the department seminars during the year, you'll get some extra content. The plan would be maybe before that day in here is to have more individual meetings with you about projects, right? So like an hour in office hours each, something like that, to help you get ready so that you have a great idea of what you want to do for the project, maybe an outline, maybe maybe a little assistance in case you need to get the data into R and get started with naming some variables and things like that. So that would be kind of the advanced work would kind of take replace that in terms of content. that's really the in for and for today, and I'll see you on Wednesday. You too? Hi. Good. How was yours?
Good. So I am taking Metrics
Mhm.
and Senior Sem,
Mhm.
both of which have projects
Okay.
in addition. So I'm gonna have like 3 projects
Yeah.
potentially.
Yeah.
So I had econometrics earlier today with Allison.
Yes.
And I have Senior Sem with Walsh.
Mhm.
And I was wondering, I talked to her a little bit about it, but doing some kind of joint project or another branch of, for
Mhm.
this project here, doing a branch off of what my project I would be doing for this Senior Sem in the fall.
Yeah.
So I was potentially looking into like having a data set. I was looking into like gun violence and correlations of stuff, events.
Yeah.
And kind of comparing how some states are approaching it. And I was thinking for maybe this class doing a branch off of that project and using some of the same data but testing it in a Bootstrap and
Uh-huh.
maybe doing that as my
Sure.
project in this one.
Yeah, that's
So
the
it
type
wouldn't
of.
be, it wouldn't be like recycling the same project, but it would be like almost a separate.
Right. But some of the introduction and some of the data description might be quite same, but
Yeah.
then the intellectual content of doing the bootstrap, explaining, why you would want
Right.
to do a bootstrap. In regression, there's a couple ways to do a bootstrap,
Mhm.
right? So you could bootstrap the data, the XY pairs,
Mhm.
or you could fit a model and get residuals and
Mhm.
bootstrap those. You could fit a model, estimate an error variance, and then do a sample from that. So there's
Mhm.
at least 3 ways to
Okay.
do a bootstrap. And so doing that on your data set would
Okay.
be a good activity.
So yeah, I just wanted to check in with you and see if I could kind of like do similar, like kind of work within
I
one
think it makes sense.
big project.
Right.
'Cause instead of doing 3 different ones.
Yeah, right, yeah.
That would be a lot.
Yeah, no, it's, I think that would augment what you're doing in your senior.
Mhm. And I feel like it would be
class,
much
so-
bigger understanding one big, if I were to do it
Yeah,
off
that's
of one
fine. I'm
central
fine with that, yeah.
idea. Okay.
Yep.
So I have my Senior Sem tomorrow, and I can check in with Walsh
Okay.
and see if that's okay with him too.
Right.
So
So I
I've
want
checked in-
more literature review,
Yeah.
more connection to economic theory,
Yeah.
and
Yeah, he's gonna want that stuff. But I wanted to do like a base project for my Senior Sem, and then I would do a branch off with
Yeah.
something with
so you have that as a
econometrics.
2-credit class both semesters, or is it 4 credits each
I
semester?
think it's 4
4
each semester. Yeah, it is 4 each semester.
Right.
So it's like we're kind of reading our butts off this semester about all the past like research projects, and then next semester is our capstone.
Ah.
And that's when we're actually doing a project, but or like our like main project, but I think we do like sub projects this semester. And I think the one big one would be that, what I'm trying to do with
Okay.
gun violence or something. But I just wanted to check in with you to see if that's fine with you.
That's fine.
Okay, cool.
Good.
But yeah.
Are you skiing this year,
Mhm.
this spring?
This-
That is,
yeah. So we, week 2, we can have contact with our coach again and start dry land
Oh.
and start working out and stuff. But yeah, it's crazy. This summer, it's crazy, like this summer and then like going into senior year now, how everything's moving so fast.
Yeah.
But no, I had an internship this summer, which was really cool. I was basically doing data management.
Oh, good. Where were you?
Enel Green Power in Andover, Massachusetts.
Okay.
So it's a renewable energy branch of an energy company.
Uh-huh.
So they're Italian-based. They're like a $75 billion revenue company. So they're like a huge global company. But it was really cool. I was working with basically for IT within the energy trading department. So I learned Python and SQL, and was like editing and
SQL
moving,
code and moving,
SQL query and moving data for the traders from out of SQL and into like other mainframes that they had. And it was super cool, super useful skill,
Sounds,
tech
yeah,
skills
very-
to gain.
It sounds like you learned a lot by doing those.
Yeah, because I had no Python experience before. So they're like, and I told them, I'm like, yeah, I don't really have any like experience. They're like, yeah, we'll teach you, no worries. And I taught myself it in the first week. Read an entire Python book and taught myself in the first week.
Yeah.
And then by the end of it, I was writing code for moving their database management and explaining it to other people in the department, which was really cool.
So you were a math stats minor,
Mhm.
so statistics minor with that?
And an econ major.
Right, oh, math minor, right?
Oh yeah, I still got to declare stats as my another minor.
Right.
I should do that sheet now. Go grab that.
Yeah, to get it on the books.
Yeah, because I'll be done with the stats minor after this class.
Right.
Yeah, because it will be. I remember talking to you about it last year. It would be stats of engineers.
22, 220, 251.
And I have stats of econ already too.
Stats econ, yeah.
Econometrics, if they count that.
Yeah, I
Maybe.
see, yeah. Mhm.
And I have my math,
Right.
which is already done.
Yeah.
Or I'll have.
Right, so it's the one thing would be how much double counting.
Yeah, or
Is
double
there-
counting what?
Yeah, right, and figuring out how it maps up, so, but, yeah, some things could be triple counted, but there's kind of a limit to what they want.
Yeah, I know, right?
For that, but still, it just happens, like,
Yeah.
so, it sounds like you would have 5 or 6 courses, maybe even that could count towards this, you just
Mhm.
need 5, so, be plenty, and they're pretty distinct from math.
Mhm.
Right. But the probability is usually one might count for, one of those might count as part of math
Mhm.
as well, so that would help out, so.
Yeah, so I'll be done. And yeah, after this semester, I'm taking linear algebra too, and that's the last class I need for my math.
Yeah.
So I'm done with my minors after this.
Yeah, good.
And I'm done with my major, other than the senior science stuff too. But somehow I'm behind 4 credits total.
Oh.
So I gotta take a winter, like some winter.
Too bad they can't give you 1 credit a semester for sports.
I know, right? Tell me about it. That'd be something. All right. Well,
Yeah.
it's good seeing you.
So in the spring is CS 202.
Computer science.
Yeah, it's computational tools for data science.
So I've never even taken a computer science class here.
Right, and so.
But I already know Python.
Yeah, I know. CS 111 uses Python.
Yeah.
So that would get you ready for computational tools. So you'd
Yeah.
be doing it in Python. But if you did it as a job experience,
I wonder. Yeah.
you know, and I don't know, that just strikes me as one that would build on that
Right.
internship experience in terms of moving data and
Yeah.
things like that. So, but Greta Pengorn,
Yep. Great. So she was my first advisor I had because I started off in the engineering.
I see. Yeah.
So yeah, I know Greta pretty well.
She would be the one teaching it, I'm pretty sure,
Mhm.
in the spring, and would know all about what background in Python you really need
Yeah.
to get into that course. So
Mhm.
She'd probably make the decision
Mhm.
if you don't have the CS 111
Yeah.
to
get
do
into
that. But maybe it's possible
Yeah.
if you actually used it.
Yeah, I know, right?
Yeah.
I had it was like one of those internships where by the end, I was super proud of what I did, like what I accomplished,
Yeah.
like teaching myself everything.
Right.
And like, I was super proud because I literally was so intimidated. But it was really cool, really satisfying summer with
Yeah.
that. So I did that in the weekdays and then I did doubles, waiting tables on the weekends. And yeah, but I got an offer to work during the school year, but 20 hours a week is just
Uh-huh.
between school and sports. That's
You know,
that's a
it's
lot.
something that, I mean, it's tempting, but it would just make your life very hectic.
Yeah.
And finishing off with strong grades.
Yep.
And if you say you need 4 more credits, you don't pick that up
Exactly.
somewhere.
Yeah. No, but and then I talked to them about maybe coming back for the next summer and doing something in the business department for
Mhm.
them.
Right.
And they said, yeah, just let us know. And they were super open to it. But again, it's not even really my field. My field's econ, but I don't want to close that door because it would be nice to have that like security blanket.
Yeah, you know, and then it could lead to something that the more business market.
Yeah, exactly.
Side of a business like, I mean, the economic choices of that size of energy company.
Mm-hmm.
They must use.
I mean, because it's insane how much wind turbine, like it costs them $1 billion